me, or you can put a comment in a comment section. I will stop and try to give your answer. Okay. Maybe if sometimes I'm going with the flow, I might read the comment a little late. So in that case, please wait. I will be answering to all the comments. Okay. So within 2 minutes, we will start the lecture. I hope my voice is clear. My voice is clear, right, Norman?
Yes, ma'am.
Okay, thank you. Yes. So starting with the lecture, before starting of any topic, that is of any of the secondary metabolites, in the last week, first I would like to say that we have already seen what are alkaloids, and this new topic for the coming 4 weeks, what we are going to study is what are glycosides. Okay. So I was sharing with you all that whatever we study should have some importance, correct? So that importance is the thing that we are going to check today. Why particularly we are studying glycosides? What are glycosides? Okay. So all that things we are going to include in our today's lecture. It is going to be an introductory lecture, an overall introduction about what are glycosides. Okay. So what we are going to cover in today's lecture will be introduction, classification of glycosides, chemical test, different isolation methods. How are we supposed to isolate different glycosides? Then glycosidal drugs according to different classes, biosynthesis of cardiac and cardiac anthraquinone glycosides, and MCQs. So this three will go on for the next few lectures. This four we are going to cover in today's lectures. Okay. And if time permits, then only we will touch anthraquinone glycosides. Otherwise, let us focus more today on introductory part and why exactly we are learning this particular class of compound. So when I say glycosides, what comes to your mind first? Glucose, correct? Similar sounding, correct? So in that case, glycosides are something that will have sugar or will have a sugar moiety. I will say not necessarily the glucose. It can be any other sugar. You must have already studied different types of sugar, hexoses, pentoses, etc., etc. So it can be a sugar with a non-sugar. Okay, and why it is called a glycoside? Because it is going to be attached. This sugar and non-sugar both are going to be attached with a bond. Okay, and that bond will be known as a glycosidyl bond. So let us see what are glycosides. Defined in general as the organic compounds from plants or animal sources which on enzyme or acid hydrolysis give one or more sugar moieties along with a non-sugar moiety. That is what I said, right? एक sugar moiety होगा और एक non-sugar moiety होगा, दोनों को मिलाएंगे तो it will form a glycoside. तो अगर एक ग्लाइकोसाइड है उसका एसिड या एंजाइम हाइड्रोलिसिस करेंगे तो क्या होगा, तोड़ेंगे, क्लीवेज, हाइड्रोलिसिस इज व्हाट, क्लीवेज. तो इसका क्लीवेज होगा या तोड़ेंगे उसको तो एक शुगर पार्ट निकलेगा और एक नॉन शुगर. The former is known as glycol, मतलब sugar moiety is known as glycol and non-sugar moiety is known as either a glycol or genin. Okay. Glycosidic bond is a certain type of chemical bond that will join a sugar, that is a carbohydrate molecule, to another group which may or may not be another carbohydrate. The glycol and aglycol portions can be chemically separated by hydrolysis in the presence of an acid or enzyme. So acid hydrolysis will give you different compounds and enzyme hydrolysis will give you different compounds. Now let us have a look at the structure. Okay. Yeah. So if you have a look here, this is a sugar and this is the genin or non-sugar part or non-carbohydrate part. When you want to join this two, okay, that is water molecule will come out and it is going to form this. Okay, so now this glycoside. Now this particular bond is known as glycosidic bond. And this hydroxyl can be a phenolic or alcoholic, or sometimes it can be an amine also. So specifically, a glycosidic bond is formed between the hemiacetal group of a saccharide or a molecule derived from a saccharide and the hydroxyl group of an alcohol. So hydroxyl group कहाँ से आएगा, जेनिन पार्ट से या नॉन कार्बोहाइड्रेट पार्ट से. Now what is this carbon called? This is known as anomeric carbon. Now what exactly is an anomeric carbon? It is nothing but it is the carbon derived from the carbonyl carbon compound. It can be a ketone or aldehyde functional group. Okay, so this can be either किसमें ketone होगा किसमें aldehyde. Example एक दूं तो glucose can be an aldehyde and fructose can be an ketone. Correct? So either ketone or aldehyde functional group of the open chain form of the carbohydrate molecule. Okay. Now, what are some of the salient features about glycon part? So, glycon can consist of a single sugar group, okay, monosaccharide, or several sugar groups, that is a oligosaccharide. Now, the sugar found in glycosides may be glucose and rhamnose, or more rarely, it can be deoxy sugars such as thimerose, which is found in cardiac glycosides. Okay. Now, sugars that are involved in glycosides are of different types, but most commonly is beta D glucose. Okay, most commonly it is beta D glucose. The sugars present in glycosides are of two isomeric forms. That is, it can be either alpha form and beta form, but all the natural glycosides contain beta type of sugar. This is very important to understand. Okay, all the natural glycosides will have beta type of sugar. Okay, तो जैसे हमने अल्फा डी ग्लूकोज, बीटा डी ग्लूकोज ये सब पढ़ा हुआ है इन अवर बायोकेमिस्ट्री, तो वही याद रखना है. इन केस ऑफ ग्लाइकोसाइड्स मोस्ट ऑफ देम हैव बीटा फॉर्म ऑफ शुगर एंड दिस इज अ good question to be asked in GPAT. Now, if you see here, this is the structure of methyl beta D glucoside. Okay, again, a beta D glucose you can see. These are different ways in how I will say how a glycoside can be written. Okay, it is Haworth projection, the chair conformation, okay, Fisher projection. So all these are the different ways how it can be written. Now, if you see here, this is a structure where there is a sugar part that is beta salicine, and this is the glycone part. Now, if you see, this is the phenolic group that is present. करेक्ट तो यहाँ पे फिनॉल के साथ वो रिएक्ट हुआ है एंड इट इज गोइंग टू फॉर्म अ ग्लाइकोसाइड नाउ लेट अस हैव अ लुक फर्दर about the nomenclature. Okay, so the rather older or trivial names of glycosides usually has a suffix in. Okay, it will have usually a suffix in, whereas in the names essentially included in the source of glycoside, for example, strophanthidyl from strophanthus. So suffix है यहाँ पे, it's not a prefix, right? It's a suffix. So in जहाँ पे होगा, that means it is the genin part. For example, again, digitoxin from digitalis, barbaloin from aloes, salicine from salix, and prunacin from prunus. However, these systemic names are invariably coined by replacing O's. Okay, it is formed by what? It is formed by replacing suffix of the parent sugar with O. The stereochemical anomeric prefix A or B and the confidential prefix D or L immediately precede the sugar nomenclature. And lastly, the chemical name of the glycone precedes the name of the sugar. It may be detailed with the help of following examples. Salicine is also known as 2-hydroxymethyl phenyl beta D glucopyranoside, and amygdaline is also known as D beta D glycosido 6 beta D glucoside. Okay, so now if you have further look at the structures, beta amygdalin, if you see here, it's a glucose part. Okay, and this is the glycone part. So this together, two sugars from here and this, okay, this is together going to form a glycoside. Okay, then again, sugar, here it is beta salicine, and this is a glycone part. Okay, so this again together is going to form a sugar, which is this 2-hydroxymethyl phenyl beta D glucopyranoside. Q pyranoside because this is a pyrene ring if you see, 6-membered. Okay, so this is how what you can see. Important क्या देखना है कि genin part or the glycone part is before the name of the sugar. Okay, यही important है देखना. यहाँ पे भले वो बाद में है but nomenclature में it is preceding the name of the sugar part. Now coming ahead, मैम ये सब क्यों पढ़ रहे हैं? This question should arise. So what is significance of studying glycosides? So it is used in traditional and modern medicines as purgative, analgesic, anti-rheumatic, emulsant, cardiotonic. Okay, I am sure you know the meanings of all these terminologies. Okay, analgesic is pain relieving, purgative is going to help in laxation or easy passage or removal of the stools. Cardiotonic is heart protective. Uh, demulcent is something that is going to soothe throat, and anti-rheumatic is for rheumatic fever or rheumatism. Okay, so all these glycosides have this multiple actions, which is why we are going to study this particular class of compounds. Now let us see, have a look at physicochemical properties of glycosides. So they are both synthesized and hydrolyzed under the influence of more or less specific enzymes. Okay, crystalline or amorphous substances that are soluble in water or alcohols, with an exception. There is an exception to it, which is nothing but resin glycosides. Can you have a look? An exception to it is resin glycosides and insoluble in organic solvents like benzene, chloroform, and ether. So basically, they will be either crystalline or amorphous substances. Now, the aglycone part is soluble in organic solvents like benzene or ether. They are hydrolyzed by water, enzymes, and mineral acids. They show optical activity, normally with levorotatory effects. तो यहाँ पे देखो, आइडियली अगर एक चीज देखेंगे तो हम लोग डी टाइप ऑफ शुगर पढ़ रहे हैं, डेक्स्ट्रो टाइप ऑफ डी, डी ग्लूकोज. But normally the optical activity is levorotatory. That is, it is going to turn the plane of polarized light towards left side. Okay. तो वहां पे D का D does not stand for dextro, but it is your DL configuration. दोनों में difference है. It is the big capital D. तो ये हमेशा याद रखना difference. While glycosides do not themselves will reduce spelling solution. अभी यहाँ पे ये statement क्यों आया है? अगर if you have understood the ahead lectures you will understand. क्योंकि हम carbohydrate पढ़ रहे हैं, which generally reduces spelling solution if it is carbohydrate. But यहाँ पे glycosides will not themselves do it. Only the simple sugars that can produce on hydrolysis, they will be able to do so with precipitation of red cuprous oxide, which is your Fenning's test. Okay, तो उसमें से अगर जेनिन पार्ट को निकाल दिया एंड शुगर बचा और वो भी सिंपल शुगर रहा, ओके, नॉट अ कॉम्प्लेक्स वन विथ 3 or more molecules of glucose. Okay, if it is a simple sugar, then only it will be able to give this test. In plant, they are believed to precipitate in growth regulation, that is sugar reservoir, and protection of plant, which is antibacterial effects. The glycosides contain sugar, but still the physical, chemical, and therapeutic properties are dictated by a glycone part. This is again important point. जो भी जेनिन पार्ट है वही रिस्पॉन्सिबल है फॉर योर थेराप्यूटिक एक्टिविटी. Sugar moiety is only going to help or facilitate the absorption of glycoside, and it will help in transportation of a glycone portion to the site of action. Okay, so only that part, I would say only that is the uh, responsibility of the sugar part. Okay, transportation or absorption. बाकी therapeutic activity कौन देने वाला है? The glycone part. Now, when we say classification of glycosides, 4 different things say I am going to teach you the classification. Okay, it can be based on glycone part, then it can be based on chemical nature of the glycone part, which means how is the what is the chemical structure of the glycone part. Then it will be based on the glycosidyl linkage. Okay, and finally it can be based on the therapeutic activity. Okay, so based on glycone part, if I have to check, they are glycosides with glucose, rhamnosides with rhamnose, pentosides with pentose, like ribose. Okay, now the sugars involved in the structure are normally the common type of sugars, except in some cases where sugars like digitoxose, cymerose are also present. Okay, some sugars that are present are digitoxose or cymerose. Okay. Then next, when we have a look at the example of different monosaccharides that are present, okay, which is glucose in salicine, rhamnose in guanine. Disaccharides का example is मतलब ये बेसिकली क्या है, ग्लाइकोन पार्ट मतलब कितना शुगर मोइटी है, वेदर इट इज द शुगर इज अ पेंटोज रेमनोज, उस पे क्लासिफिकेशन। तो अगर दो एक सिंगल शुगर है तो ग्लूकोज, डाइसैकेराइड है that means two sugar, it can be gensho bios, okay, which can be again glucose plus fructose or something mixture of that two, okay, that is present in amygdalin. Then tri ka example is trophanthoside present in strophanthus, tetra ka purpurea glycosides, and there are deoxy sugars, okay, like digitoxos and cymerose. Now, these deoxy sugars have specific action, okay, that we will be studying when we study drugs under this class of compounds. They have also have specific tests for identification, okay. Second is based on the glycone part. ये best way है again, parent structure सिर्फ मैंने यहाँ पे दिया है because individually drugs के structures काफी है. Okay, so I just want you all to know the parent structure. There is no point reading out this. Okay, I will just explain you one or two of them so that while moving through the PPT, you know that what are you going through. Like if you see anthraquinone or anthracene glycosides, which is present here, sterols or cardiac glycosides, again, it can be two. Either it can be a C23 ring or it can be a C24. So either it can be a bufadienolide, which is C23, or it can be bufadienolide is C24, or it can be a cardinolide, which is C23. Okay. Now, what you see here is also known as the lactone ring that is present. Okay. This ring is nothing but the lactone ring. The examples are given like digitalis, quill, thevesia, and strophanthus. Then we see saponin glycosides. ये वही ग्लाइकोसाइड्स है जिसको इफ यू वो फोम टेस्ट जो करते हो ना तुम लोग इन योर लैब, ओके, ये वही ग्लाइकोसाइड्स है, सैपोनिन. सैपोनिन itself is soap forming. Okay, example for this is Brahmi, Dioscorea, Momordica, Licorice, Quillaya, Ginseng, etc. Then cyanogenetic or cyanophoric glycosides like bitter almond and wild cherry. So cyanogenetic मतलब क्या, cyanide bond जिसमें होगा, okay, there will be a cyanide bond. Then there is isothiocyanate glycosides like sinigrin that is present in black mustard. This is an example of isothiocyanate. Isothiocyanate मतलब isocyanide, इतना ही समझ लो, CN के बदले NC bond, इतना ही है. Then flavonoids, proper flavonoid structures जिसका होगा, ओके. तो फ्लेवोनॉइड क्यों, बिकॉज जेनिन पार्ट जो होगा वो फ्लेवोनॉइड होगा, इसको ही आगे शुगर मोइटी अटैच होगा, तो दे विल बी क्लासिफाइड एज फ्लेवोनॉइडल ग्लाइकोसाइड्स. ओके. Furanocoumarins and coumarin glycosides, aldehyde glycosides, phenol like your willow bark, beerberry. Then there are steroidal glycol alkaloids. Okay, ये हम लोग एक स्पेसिफिक ग्लाइको अल्कोलॉइड पढ़ेंगे, तब आई विल एक्सप्लेन यू व्हाट इज दिस क्लास एंड व्हाई आई हैव नॉट पुट हियर द स्ट्रक्चर ऑफ इट. एंड फाइनली देयर आर ग्लाइकोसिडल बिटर्स और मिसलेनियस ग्लाइकोसाइड्स. they are classified specifically as bitter compounds. Okay, based on glycosidal linkage, one more approach of classification is by considering the linkage between the glycone and the glycone part. So basically, all types of glycosidal linkages are occurred by interaction of hydroxyl group of glycone and hydrogen coming from any of these radicals like CH, SH, OH या NH. मैंने बोला था ना एक कि glycosidal linkage जो form होता है उस पे भी एक classification. So that is based on this. Okay, based on the linkage. This is that classification. So hence by elimination of the water molecule, linkage or a bridge is formed. And type of glycoside formed is named by putting the prefix. अभी इसका एग्जाम्पल देखते हैं, like C glycoside, N glycoside, O और S. C. First we see what is a C glycoside. तो basically यहाँ पे CH group होगा, तो water तो निकलने ही वाला है. Okay, so water will flow. So what will be the bond will be like Glycone C, a glycone. Like you can see here, glycone C and a glycone. There is no O here. Okay, this also you have a look. Glycone C, a glycone. But cascaroside can come under both because यहाँ पे if you see it is also having O molecule linked to sugar. Okay. So this is a type of C glycoside. Example is anthraquinone glycosides. This is an anthraquinone ring that we saw. So anthraquinone glycosides such as cascarosides from cascara. तो कंफ्यूज मत होना गाइस, पहले हमने जो देखा वो केमिकल स्ट्रक्चर के हिसाब से था और अभी हम बॉन्ड के हिसाब से देख रहे हैं, ठीक है. They are not hydrolyzed by heating with dilute acids, but by oxidative hydrolysis with ferric chloride. Cochineal contains C glycoside in form of coloring matter called carminic acid. So carminic acid is a type of C glycoside. Next, we have a look of O glycosides. Glycone plus glycone water plus a glycone. Again, here removal of H and OH will give you glycone O glycone. Like you can see here, oxygen mixed में है. So this is a kind of a O glycosidal linkage, which is very common in higher plants like senna, rhubarb, frangula, salicin, etc. They can be hydrolyzed by heating with dilute acids or alkalis into a glycone and sugar, that is glucoranilin and amygdalin. Next is S-glycoside. Okay, in this sugar molecule, that is the hydroxyl group of glycol, is combined with thiol. S मतलब sulfur. Sulfur जहाँ पे आता है, we also name it as thigh, right? Thiol. Thiol group or sulfhydryl group of a glycol. Okay. Now their occurrence is restricted. This kind of glycosides can only be seen in case of isothiocyanate. Example like you can see cinegrine from black mustard. तो ये classification isothiocyanate में भी आता है cinegrine, and this will come here also under S glycosides. I hope this is clear and you have no doubts. If you want anything, I will repeat it once again. Then we see N-glycosides, in which sugar molecule is combined with amino group of a glycol. Okay, nitrogen of the amino group of a glycol, like nucleosides, where amino group of base reacts with the hydroxyl group of ribose or deoxyribose, like adenosine, which is widely distributed in nature. So if you have a look, this is a class adenosine. ये क्या है? What is it? It is a purine base, correct? So this can be seen in case of nucleosides. एक होता है nucleotide and एक होता है nucleoside, correct? So nucleosides we have ATGC4, adenosine, guanosine. Okay, you know it better. Again, biochemistry. And last classification is based on the therapeutic activity. Matlab, see, this classification is very general because I will again say not very helpful type of classification. Because अगर for example यहाँ पे purgatives में xenosides, cascarosides, aloin and barbaloin है, कार्डियोटोनिक्स में डिजिटॉक्सिन, डिगॉक्सिन, स्ट्रोपैंथस, सिलारिन है, एनाल्जेसिक में सैलिसिन, एंटी रूमेटिक गार्सिनिया एंड एंटी अल्सर में लिकोरिस. बट इफ यू हैव अ लुक, ओके, पर्गेटिव्स के अंदर और भी कोई आ सकता है, ठीक है. So I will not say this is a very acceptable classification because again aloin and barbaloin, some constituent might have some other activity as well. Okay, so again, so not very helpful, but this is a type of classification based on therapeutic activity. Next, which I had told is we are going to see isolation of glycosides. How particularly glycosides are being isolated. Okay. So if you see, this is with the help of Soxhlet apparatus. I hope this GIF is visible to everyone, okay, in the way it is moving. So what is done? This is nothing but Soxhlet assembly, okay, very well explained by the GIF itself. What happens is यहाँ पे boiling point पे solvent रखा होगा, जो boiling point पे boil होगा, धीरे धीरे ऊपर जाएगा, and यहाँ से कंडेंसर जो होगा वो वेपर्स नीचे डालेगा. ठीक है, वेपर्स नीचे डालेगा तो क्या होगा, ये धीरे धीरे दिस इज गोइंग टू राइज अप, तो इसमें क्या होगा, दिस विल हैव योर ग्लाइकोसिडेल ड्रग दैट इज प्रेजेंट। ओके, और योर क्या बोलते हैं उसको, एक्सट्रैक्शन जिस ड्रग का करना है, ओके, वो प्रेजेंट होगा। ओके, तो वो धीरे धीरे इसमें से वेपर्स कंडेंस होके नीचे आएगा। दिस सॉल्वेंट should be suitable for extracting glycosides, so you can have in this case alcohol or hydroalcoholic solvent, and then when both the levels are equal, with the help of a siphon tube it is going to flow down. If you see, this oxalate extraction is also explained as a series of short maceration because the drug is constantly macerated. Okay. Now, in this, what is done is firstly, it is powdered. Okay, and continuous hot percolation also you can say, because drop by drop गिर रहा है ना इधर sample. Okay, तो sample absorb कर रहा है, so you can also say it as a percolation using Soxhlet apparatus. During this process, various enzymes that are present in plant parts are deactivated due to heating. The thermolabile glycosides, however, are extracted at temperature below 45 degrees Celsius. Now, this extract is treated with lead acetate, okay, to precipitate out tannins and other non-glycosidal impurities. Excess of lead acetate will be precipitated as lead sulfide by passing hydrogen sulfide gas. Then the extract is filtered and concentrated to obtain crude glycosides. Okay, finally what we want is crude glycoside. So excess of tannin सबसे पहले निकाल रहे हैं लेड एसिटेट डाल के, तो tannins निकल गया तो क्या बचेगा फिर, crude glycosides, and this will be obtained in pure form by making use of processes like fractional solubility, fractional crystallization, other chromatographic techniques such as CLC and column chromatography. So by this you can isolate a pure form of glycoside. So this is the isolation of just the crude drug of glycosides. Okay, and then to obtain the pure form, you will have to do it the further by chromatographic techniques. Okay. Now, what are the different qualitative or chemical tests? Okay, so glycosides are the compounds with organic molecules having attached glucose or any other mono-oligosaccharide unit. Generally, aqueous or alcoholic extracts of crude drugs will be tested with specific reagents for presence of various types of glycosides. Okay. Now, to understand each of this, we have to understand each of the test involved in this glycosides. Okay. जैसे we have anthraquinone के लिए bond triangles and modified bond triangles, saponins के लिए hemolysis and foam, steroidal के लिए है, कार्डियक के लिए, तो this basically is a flow chart to remember कौन सा टेस्ट किसके लिए है. Now वो टेस्ट एग्जैक्टली कैसे परफॉर्म करना है और and what are the reagents involved in it, that we are going to see in the next couple of slides. Okay, so first if I have to say about the anthraquinone glycosides, the first test, which is bond triangles test, okay, in that what is done is 1 gram of drug is taken. Okay, I am sure you must have performed this also, but now today we are going to understand why exactly we are adding those reagents. Okay, and you add 5 to 10 ml of dilute HCl. सबसे पहले HCl क्यों डाला है हमने ड्रग में, हाइड्रोलिसिस के लिए. Okay, we have to hydrolyze the bond, okay, of the sugar and non-sugar. Then filtrate will be extracted with chloroform or benzene. क्यों, क्योंकि स्टेरॉइडल पार्ट है तो क्लोरोफॉर्म बेंजीन में आ जाएगा. ओके, एंड देन यू add equal amount of ammonia to it. So now formation of pink or red color in ammonical layer due to presence of anthraquinone moiety. Correct, anthraquinone तो पार्ट आ गया है बेंजीन में. ओके, एंड व्हेन यू ऐड अमोनिया टू इट, वो कलर जो है, सॉरी, एंथ्राक्विनोन इज देयर इन योर द अदर पार्ट. ओके, क्लोरोफॉर्म में बाकी इंप्योरिटीज निकल जाएगा, तो कलर जो होगा वो एंथ्राक्विनोन मोइटी देगा. It is going to react with ammonia to give this color. Okay. Modified bond triangles में क्या होगा? Because it is a C type of glycoside, it does not undergo hydrolysis by heating with either alkali or acid, but it may be decomposed with ferric chloride due to oxidative hydrolysis. See, ये important है, अगर alkaline और acid hydrolysis नहीं देता है सी टाइप ऑफ ग्लाइकोसाइड्स, तो उसको तोड़ने के लिए वी ओनली कैन डिकम्पोज इट, दैट इज वी कैन हेल्प इट अंडरगो ऑक्सीडेटिव हाइड्रोलिसिस. ओके, सो उसके लिए क्या चाहिए? फेरिक क्लोराइड. ओके, एंड HCl. HCl तो उसमें भी डाला था, फेरिक क्लोराइड इज द थिंग वी नीड. सो व्हाट इज डन in this case? Dilute HCl followed by ferric chloride is added. Boil it for 10 minutes. Again, this will only happen if you boil it nicely and if there is proper hydrolysis of the sugar that will take place. Filtrate will be extracted with carbon tetrachloride or benzene. That is what CCl4 or benzene. And again, same. बाकी का process same है. सिर्फ ये modified क्यों है? Because ये C type of glycosides के लिए है. Okay. And equal amount of ammonia solution. Formation of pink to red color due to presence of anthraquinone moiety. This is used for C type of anthraquinone glycosides. This is the bond triangles test. Ammonical layer में दिख रहा है, nice pink color. Okay, this is nothing but bond triangles test. Then for saponin glycosides, okay, drop of blood on slide will be mixed with few drops of aqueous solution. RBCs will become ruptured in the presence of saponins. Okay, so if you see this three different test tubes, okay, can any one of you write in comment if I have to say A, B, and C? Okay, so can any one of you write in comment section which has gone proper hydrolysis or what exactly this is showing? Comment section में लिख सकता है कोई? I am waiting. No one? No one would like to write? Okay, then in that case, I will explain. Okay, so if you see here, this clear test tube, okay, there is PPT settled down. So there is proper hydrolysis of RBCs that must have taken place. Okay, सारे टूट गए होंगे, इसलिए you can see quite clear, whereas these two are quite turbid. Okay. Foam test is when you add 10 to 20 ml of water and for few minutes, shake for few minutes, and foam should at least persist for 1 to 2 minutes. Then only you can confirm that it is a saponin glycoside. The foam should, it's a very easy and I would say it is the most easiest test. The foam should persist for 1 to 2 minutes. Okay. Then steroidal and triterpenoidal glycosides के लिए specific for steroids. Okay, steroids and triterpenoids both are different. I hope you know that the structures of both are different. Of course, that we will see ahead also when we study individual drugs. But as of now, remember and understand that steroids and triterpenoids both are different. So Liberman Burchard is specific for steroids. In this, alcoholic extract of drug was evaporated to dryness and further chloroform was added with few drops of acetic anhydride. Okay, acetic anhydride क्यों डाला है? See, this understand it is a steroidal. So बहुत moiety is quite big. It's a steroid, right? So you need to have a strong acid or strong alkali for the hydrolysis. Followed by Kong sulfuric acid from side wall of the test tube to chloroform extract. If there is a formation of violet to blue colored ring at the junction of two liquids, it is a test used to detect cholesterol. Okay, this is the test. It indicates the presence of steroid moiety. Again, this is also the test to detect cholesterol. Now, color. Why is this color? Is due to the presence of hydroxyl group of the cholesterol reacting with the reagents and increasing the conjugation of unsaturation in the adjacent fused ring. तो केमिस्ट्री क्या है ये भी यहाँ पे दिया है behind the test. Okay. Next is Salkovsky test. In this, alcoholic extract of drug again will be evaporated to dryness, and then further it will be extracted with chloroform and added form sulfuric acid from side wall of the test tube to the chloroform extract. Formation of yellow color at the junction of two rings will indicate the presence of steroid moiety. So this is not specific for cholesterol, but this Lieberman-Burchard is very specific test for cholesterol because hydroxyl group is going to react here. Okay. Yeah. This is your Salkovsky test, how it looks, yellow color at the junction of two liquids. Then next is for steroids and terpenes. दोनों के लिए कॉमन ट्राइटर्पेनॉइड और स्टेरॉइड के लिए एंटीमनी ट्राइक्लोराइड टेस्ट दैट इज SbCl3. तो अगेन सब में याद रखो स्टेरॉइडल टेस्ट कोई भी कर रहे हैं तो अल्कोहलिक एक्सट्रैक्ट ही लेना है और उसको ड्राई कर देना है, फिर उसमें क्लोरोफॉर्म डालना है एंड फर्दर यू ऐड द डिफरेंट रिएजेंट्स अकॉर्डिंग टू डिफरेंट टेस्ट. Here you are adding antimony trichloride to containing 20% of acetic anhydride. Again, formation of pink color will indicate presence of steroids. This will form yellow color with unsaturated steroids and triterpenoids. Specific for terpenes is trichloroacetic acid, where triterpenes on addition of saturated solution of trichloroacetic acid will form colored precipitate. And there is one specific test for ketosteroids with the Zimmermann test. This has also been asked once in GPAT. Okay, specific test for ketosteroids. Okay, in this meta-dinitrobenzene solution was added to alcoholic solution of drug. On heating, it is going to form violet color in the presence of ketosteroid. Next, we see test for cardiac glycosides. Okay, cardiac glycosides क्या है? Something that is going to help in cardiac protection. Okay, so हम लोग different types पढ़ेंगे उस मतलब different drugs पढ़ेंगे उसके अंदर, but तभी मैं ये test repeat नहीं करूँगी. So I want you guys to pay attention here. Okay, that time I am going to ask a test. Okay, now this Keller-Kiliani test is specific for deoxy sugars. You remember मैंने स्टार्टिंग में इंट्रोडक्शन में बोला था there is something called as deoxy sugars that we will study ahead. So they are nothing but sugar with containing one less oxygen. Okay, so in this again to the alcoholic extract you add 0.5 ml of strong lead acetate solution. Filtrate will be extracted with chloroform and chloroform extract further will be added or dissolved in 3 ml of glacial acetic acid followed by addition of few drops of ferric chloride. The resultant solution will be transferred to a test tube containing 2 ml of concentrated sulfuric acid, and here the reddish brown color that is formed which will turn bluish green after standing due to presence of digitoxos. So ये जो है this is very specific color test. You can see a reddish brown color. Okay, that is for Keller-Kiliani. और जो digitoxos है वो deoxy sugar है. It is going to be come under the type of deoxy sugar class. Legal test क्या होता है? In this 0.5 ml of strong again lead acetate solution is added, shaked, filtered, filtrate will be added with chloroform. Same thing is done. Okay, what is different here? Residue will be dissolved in 2 ml of pyridine and sodium nitroprusside. Okay, followed by addition of sodium hydroxide solution to make alkaline. So formation of pink color in presence of glycoside or a glycol moiety. Okay. Here you can see this. This is nothing but your Legal's test. Next is test for cardiac. Again, same. तो लीगल, बल्जेट, कैडेज और केलर किलियानी, ये 4 टेस्ट है फॉर कार्डियक ग्लाइकोसाइड. ओके, बालजेट में क्या है? दिस इज डन ऑन द थिक सेक्शन ऑफ लीफ ऑफ digitalis. When it is dipped in sodium picrate, it forms yellow to orange color in presence of glycols or glycosides. Okay, so this is nothing but your Baljet test, and Caddes test is nothing but 3,5-DNB, that is 3,5-dinitrobenzoic acid is added of the drug. Few drops of sodium hydroxide is added. 2% solution will be added, and formation of purple to pink color will indicate the presence of cardiac glycoside. So this test is again, these 4 tests are specific for cardiac glycosides. Next we see for coumarin glycosides. So again यहाँ पे क्या है? अल्कोहलिक एक्सट्रैक्ट और फेरिक क्लोराइड डाल दिया. ठीक है, तो फेरिक क्लोराइड से कलर तो आएगा, but further when you add Kong's nitric acid, okay, and if it turns yellow, then it will indicate presence of coumarin. Otherwise कोई भी extract में if you add ferric chloride and if it shows color, that means it is tannins. But further when you add nitric acid and if it turns yellow, that means they are coumarins. समझो, हाँ, ये ferric chloride डाला और color आया तो tannins, but when further you add nitric acid and then if it changes to yellow, it indicates coumarin glycosides. Fluorescence, alcoholic extract of drug mixed with one normal NaOH. Development of blue-green fluorescence will indicate presence of coumarins. Next is test for cyanophoric glycoside. Cyanophoric, okay. So in this, powdered drug will be moistened with water in a conical flask. You see this test is done like this only. Filter paper is impregnated, matlab attached with sodium picrate solution, followed by sodium carbonate solution, which was trapped in the neck of the flask. HCN, when it is liberated from cyanogenic glycoside by enzyme activity, it will react with the sodium picrate to form reddish purple sodium isopurpurate. Okay, तो basically इसमें क्या करना है? Simple. You have to just moisten your drug with water, okay, and add sulfuric acid. That's it. तो liberate होगा धीरे धीरे, तो इसका color change होगा. That is the test. Okay. Another test for cyanogenetic glycosides can be cuprocyanate, ferriferrocyanate, and precipitation of mercury from mercuric nitrate. Okay, so again, सब में chemistry same है. I am not reading out the test. Okay, but what we need to understand, chemistry is same, that is generation of HCN gas. Okay. Then comes the test for flavonoidal glycosides, like your Shinoda, ammonia test, vanillin hydrochloride, and ferric chloride test. अभी flavonoid के लिए सबसे important test है Shinoda, where you add magnesium turnings and dilute HCl. There will be magnesium turnings जब add करोगे, there will be formation of red color, which will indicate the presence of flavonoids. Now this is the best test for flavonoids. And to the alcoholic extract of drug, zinc turnings and dilute HCl can be also added. If it forms deep red magenta color, then it indicates presence of dihydroflavonoids. Okay, so either you can add magnesium turnings or zinc turnings. Magnesium turning will indicate your flavonoids and zinc turnings will indicate your dihydroflavonoids. Okay, vanillin hydrochloride test में क्या होगा? Alcoholic solution, formation of pink color will indicate presence of flavonoids. Ferric chloride में again few drops of ferric chloride you add, blackish blue color will indicate presence of flavonoids. याद है क्या? उसमें भी सेम किया था हमने, किसमें? coumarin glycosides में. बट क्या आगे किया था? See, connect the test, then only you will be able to remember them. ओके, वहां पे आगे क्या किया था हमने, उसको फर्दर ट्रीट किया था नाइट्रिक एसिड के साथ, और अगर वो येलो कलर देगा देन इट विल इंडिकेट प्रेजेंस ऑफ काउ मैरिन. ओके, दिस इज हाउ शिनोडा टेस्ट गिव्स कलर. बट इतना अच्छा कलर you can get if the flavonoids are present in ample amount, वरना और faint color आता है. And this is your vanillin hydrochloride. Okay, sorry, this is your ferric chloride test. Okay, so here we come to an end of our introductory PPT. Okay, and I think I will stop before, because for 2 minutes I will wait for your comments as well if you have some doubts in the entire lecture. Okay, I'm stopping today because if I start up the new class of drugs, so next lecture after a week, I don't know kitna recollect hoga. So it's better to stop here, okay, and start with with the first class of drugs in the next lecture. Okay. Yes. So any doubts, please add into your comments. I am waiting for that. Okay, I have quite a few comments. Ma'am, it is important to remember chemical used for test. Yes, it is important, Divya, because it is exam. Mostly, it is asked in exam. Okay. Yes. So I think that is it. Okay, you have to be very cleverly. Matlab, you have to remember the chemicals used for test. It is important for your GPAT. Okay. So that's it. Anyone has any other doubts, or I will end the lecture here. Any more doubts? Okay. Thank you guys. I will end the lecture here. Okay. How frequently are the tests of the lesser known glycosides like cyanogenetic type? Yashish, I was just about to end. Before that, I will answer. Take up your doubt. So yes, one chemical test is always asked, but I cannot assure you that it will be glycoside or alkaloid or tannin. Okay, so it can be any type of glycoside or alkaloid or any other secondary metabolite. Yes, but there is one 4 mark question definitely from this class of compounds. ग्लाइकोसाइड्स में से भी एक क्वेश्चन होगा, बट वो केमिकल टेस्ट पे ही होगा. दैट आई कैन नॉट अश्योर यू. ओके. You cannot say that cyanogenetic is a lesser known type of glycoside. Okay, हम लोग दो ड्रग्स पढ़ रहे हैं, that does not make it less important, that class. Okay, it can be asked from that also. Okay, so thank you everyone. I will end the lecture now. Thank you.